Hey, let's have me. Come on, you. the microphone, Muppet. Ah, I'm here. Viewers. Wow, we have a viewer. Oops, sorry. Let's stop this thing, eh? Let's stop that, shall we? What are we doing today? Oh, okay. Stream monitor. Stream is looking good. We're live. And broadcasting today on a lazy day. Sunday. It's me, Fraser Sharp. Just call me Bladez, because we're doing something different today. I'm going back to what I do best. And that means a project. And I've decided what I'm going to do. I've had a little bit of feedback from the community that passes by on this channel, and I think I've made a good decision. So, from the top, what the heck are you looking at? Me designing something. Now, let's see if I can get my design out on my screen. Yes, I can. So, what we have here is, believe it or not, the beginnings of a 3D engine. I've never made one. I've never made a complete 3D engine because I always get stuck and start researching. Well, I don't get stuck. I just start researching things because I don't like what I'm doing. So, this time, I'm going to take whatever advice I can get from anybody on how to complete a 3D rendering engine. So, by that word package at the top, I'm guessing I'm going to be using Java, which is fine. I guess I can. I need to know what I'm going to do with the input. The last trigger on this that I've got is the input. Will that be core or will it be rendering? I'm not sure. I just think it's going to come under the camera. It goes with the window. Alright. I'm going to make it part of this anyway because there's the window. But we haven't got a camera, so input isn't really there. But I'm still going to have input. That might be core. Yeah, I'll leave that there, like that. With a window input and a mesh loader and renderer, you can put an object on the screen. If I do the bare minimum, put an object on the screen from disk, using an OBJ context, we've got the test models and stuff. Texture, yeah, we'll need a texture. Got the render engine. Right, okay. So what I've been working on the last week is this mesh loading thing, OBJ models. And that's exactly what I want to do first, because I've had an idea of splitting it down so that we can get an indexed model out of the OBJ model. So we'll have an OBJ index, an OBJ model, and then we'll have an index model out of the two. I think we should try this. Do a mesh loader inside of a rendering package. That can be a package. So, sit back and relax and think. The setup should be easy, I guess. Create new project. Project name. Let's see. Stuff it. Yeah. That's how it's supposed to be. That's Java-ized, isn't it? Having a com dot. I think I like that. It's going to be welcome to the Bladez engine 3D test program. That's what this is going to be. Okay. So this is going to be the engine tester, not really the main, but main will do. All right. All right, we need some libraries. Where are my libraries? Good, they're here. I'll have you libraries are actually at the top level, so I can use the same libs. So you click on the first one, you go all the way down to the bottom, and there's quite a few libs here. There's a lot of stuff I don't need or want. But I don't care. God, it keeps going, it keeps going, it keeps going. How much more of this can there be? Alright, that's the bit that I need at the end. Okay. Blah de blah de blah. Okay. Three 3.2.3. Okay. Does it run? Yes, it does. Welcome to the Bladez Engine 3D test program. Yay! This is good already. So, under source, we're going to grab a package. And the new package is going to be called rendering. And under here, we are going to have a package for mesh loading. Yeah. Oh dear, Muppet. Oh, it's rendering dot, isn't it? Yes. Mesh loader. Okay. How do I just now get something under that? I think I've done this wrong. I don't know how to do that properly. That's a bad way of doing it. No. So if I put which one? Render engine. That'll do. Yeah, it's put it in the wrong place. So, do that again. Want it under source, new, package, rendering. Ah. I'm good at this kind of thing, aren't I? Source. Thank you. New package. I always find this part difficult because I don't think this is the way most people would probably set up a project. I set it up usually towards the beginning for packages and stuff, directories as they are. So a Java class called, what did we choose? What did we choose? Render engine, okay. I can go in there. Doesn't do anything at this point in time, it's just a placeholder. Package. And this was for mesh loader. Mesh loader. Why are you there? Gotcha. That's alright, that's working. Alright, under mesh loader, we would like index model, obj index, and obj model. Okay. So indexed model. Excellent. Obj index. Yeah. Fine. Don't think about it. Just do it. Another class, which is going to be obj model. Lovely. Cup of coffee time. Cup of coffee time. Well, hey. And this should allow me to build an obj model in a completely different way to what I've been doing so far. Well, I hope it does anyway, otherwise we're in trouble. So, what are the kind of things we're going to need? We've been going through this long enough, haven't we? So I think we already know. Let's simplify it all out this time, because we're not going to have loads and loads and loads of data in this. All we're interested in is the obj model itself. So, and I'm going to do everything properly this time. So it's going to be a private array list, I suppose. Yeah, it's Java util. Okay. We are going to need a vec3, which doesn't exist. Well, that's vertex, isn't it? Let's be honest, we know what a vertex is by now, I hope. Or a vertex. We need a vec3. maths 3D. And in here, new Java class, vec3 is lowercase for this because it's maths. This is going to hold a private float. Yeah, I'm going to use m_x. I'm going to use member variables this time. Private float m_y. Private float m_z. Alrighty, looking good already. Yeah, go on, we'll have constructor. Shift float. Okay. It's Alt insert, isn't it? Is it Alt plus? Yeah. Getters and setters. Shift down, down, down. Return. There we go. Done. That'll do. Save that out. There you go. Made a vec3. There you go, maths 3.3. Yeah, that's fantastic. There you go. And this is how I'm going to program. Spontaneously. Me spontaneous. That's never happened in my life. Everything's planned. I do stuff all that's spontaneous in my life. Private. Well, I think we'll have an array list of type vec2. You can see what's going to come up here now, can't you? m_, these are textures. Texture. Oh, I'm not going to put it in, no, just put textures. Texture UV. That's what they are. Yeah, we haven't got vec2 in our maths class. New Java class. Vec2. If anybody's wondering why my maths class is vec3 and vec2, it's because that's what GLSL uses. So all I do is I use their naming convention, as it were, to make things correct. So that when you're doing the GLSL, it's not foreign language, it's the same language. So it's a private float m_x and a private float m_y. Oops, wrong key. Alt insert constructor, shift down, okay. Alt insert getters and setters, shift down, done. There you go, that's that done. Save. There we go, import class. Yeah, it's that easy to program. That's all you have to do. Just tell it what you want as variables and ask it to do the rest. Oh, who says Java's difficult, eh? Java's one of the easiest programming languages I've come across. That's why I'm going to do it in this language rather than C++, because this converts to C++, and I'll do that conversion after. That'll be easy. We'll have an array list of vec3, and this will be the last one, which will be probably normals. I think we'll have. Yep, that's okay. And then we'll have a private array list. This is where we're going to get a bit different. So we're going to call it. Why is this closed down? Why have I got red lines? Oh yeah, it's because I'm writing it. And this is going to be the obj index. There you go, it doesn't go red because we've already got it. M underscore. I love this game. Indices. So we are going to have to at least set up a constructor in there, I think. What kind of constructor do we want for it? Don't think we want any constructor. Can't think of one. It's just going to be a hash table, isn't it? Yes, we want to generate a hash table of indices. I'm going to leave that alone for now and carry on with the model, I think. Yeah. I think we'll be safe to do that for now, but I'm not sure. When we get to use it for the first time, we might come into trouble. Because we are going to create a hash map for it, or from it. Yeah, I'm going to have a class that's a hash map. Right, private. Some things I do know I need from my C++, which is where I'm taking this from, really, is a private boolean. And that's going to be m underscore has textures. And I'm going to reintroduce from the C++ thing the boolean for m underscore has normals. It's going to become more important now. Because we might be doing our own normals. So that's going to be interesting. I want to introduce a mechanism where I can decide if we generate the normals rather than take them out of the obj file, as I've been experiencing quite a bit of problems with that in Java for some reason. And this will convert better to C++, I think, with the booleans in. So yeah, if we need more than that, I'll come back. But those are the base needs. I mean, if we look at the C++ one, we'll be virtually the same, won't it? Yeah. Let's have a constructor. Public will make it, and it'll be an obj model. And all it's going to do is take in a string file. Name. Yeah. It's going to do nothing. No, I want it in the constructor. There's a big reason for it. I might be using this multiple times and it's not a singleton. Underscore positions. Sorry. Vertices equals a new array list. M underscore text UV equals a new array list. Yeah, I'm going to do all of these here. It's not hard to do. M underscore normals. That equals a new array list. And M underscore indices equals, guess what? It's going to be a new array list. I'm just typing it in as it gives it to me. Really? I don't care if this is correct or not. Has textures is the next one. We'll start it off as false. And M underscore, the last one is has normals. Equals false. I think that'll do that. That's our initialization. That's looking good. Don't like that there. That's better. Nice. Good setup. We can get a bit better over here. Alright, so this is the OBJ model loader. Let's say hello to everybody, because I have neglected my duty. Let's go to this message window. Oh my god, I think my cat's passed out on me. Make sure everything's working on the chat system for you. Yes, it is. At 11:33, it says that. Wow. Alright, let's go back to the windows. Lovely. Right. Buffered. Reader, I suppose. Must be. We'll call it mesh reader. Do we have to? Because it's not. It's the OBJ reader. Or file in. I usually call it file in, so I'm going to call it file in. There we go. Equals null. Doesn't have to equal anything. And of course we're going to have the try catches, aren't we? So we'll start it here. Or we'll start it when it asks for it. How's about that? So it's going to be I haven't done anything complex yet. Alright, let's okay. Oh, it's not hash on here, is it? Python. Doing Python yesterday has just messed my brain up a little bit. Initialize variables. Okay. Initialize the file reader. I like the way it accepts the American. Let's put it in English. Oh, it accepts English as well. Okay, we'll stay with American. I don't mind spelling in American. And that should do. Coffee. Need more coffee. This is going to be a very, very slow ordeal. I can see it taking all week just to do these three. Because of ifs, buts and maybes that I'm going to think of. Ah, this is where it gets difficult. All right, let's try. It's gonna ask me for a try catch, isn't it? So file in equals a new buffered reader, which is a new hit return, a new. Oh, good, just go down and put the semicolon in there. It's easier. And that's going to be a file reader. And that's going to be file name. Okay, this is where it happens, isn't it? Yeah, it is. Just put that down there at the bottom, because we're going to have to do everything within here now, aren't we? So I've got to keep within scope. So we'll keep the line within the scope then. So the next thing we're going to do is initialize our string line. We call it normally. Okay. Should I alter file name? Maybe. Take this for reference. I'm not very good at remembering things, which is why I can program in any language. Yeah, I will. I'll do that. I'll do that line there. That's what I was thinking. So we only have to put the name of the object. Put that instead. There we go. Lovely. Variable to store each line red. Okay. That sounds okay. Bring that off the edge, just one more. There we go. It's a bit of a long line, that, but that's because of the indents. I wonder how wide that line is, just out of interest. Because I don't like it. I'm going to put file. No, I'm not. I'm going to put string file equals that. File. Oh yeah, you want your space, don't you? Semicolon. File to file plus path. So now when we go back down here, we can just put file. Still a bit long, that line. Okay. That looks better. I'm not happy that we're restricting ourselves to OBJ. I want to change that to something different. I want to do a converter. I think if I can get this working, I'll do a converter. We'll change that. We can just probably take that straight off and just have a file name without an extension. That would be nice. And get rid of .obj. Nearly English. The reason for that is that you can make a file converter then for anything you like, and you'll after converting the file, you will have a standard input for your OBJ model. But then will I need the OBJ index? No, that's a bad idea because this is actually titled OBJ model. That's a bad idea. I might turn it into a generic one later, when I review this code later on. I would like the code working fully before I review this kind of thing. We could still leave a to-do in though. I refuse to put a to-do in because it's not going to affect the outcome. Right, we've actually got to this part, and it's going to be a while loop. While. Okay, line equals something or other. I don't know. I've got to make some up, Anna. Oh, God. Oh, God. What can we do? I need a mesh reader. Do we have one? No, we don't. Dooby-dooby-dum-dum. No idea. Anybody got any ideas? Nope. Nothing on chat. Damn it. I need a mesh reader of some kind. I've got one. I'll use my reference at the bottom. That one. Yeah, I'll use that one. Okay. Alt-enter. Reline. Yeah, that's okay. Never mind. I think that should be okay. I wonder if it needs to be static or not. not sure. Ah. That's it. Equals read okay. I don't have confidence in Java. Well, not as much as I do in C++ anyway. I can just write stuff in C++ and I know it's going to work. That's not going to be read line. See, it works. And you need a buffered reader. A buffered reader file in. There we go. I don't need a buffered reader though, obviously. Duh. Is not equal to null. Why can't I do a while loop like that? Oh, annoying. Ah. 1, 2. Yeah, that's right. Is it a small W at the beginning of that? Yeah, of course. It's Java. You can't just make up the languages you go along, Blades. You do actually have to follow it. What was I doing? Oh dear. Bloody try catches, I don't like them. I might make a utility package for that. So it doesn't belong in here. This is the OBJ model. The actual read line doesn't really belong in here. But it does for now, because it works. So, we're in a while loop now. So this is going to be the main loop for reading. Okay. I want to partition this off. From there. Right, that's better. It's partitioned off now. I've got to be able to find things on a page, and by doing this it helps me locate the main loop, especially the main loop, because this is where most of the work's going to happen. Right, so what we're going to call the stowing. Should we just call it split line? What have we called it before to make it follow on so I can do referencing if I need to? No idea. Here we go. Current line. Yeah, this is right. It's basically the same at this point. So I'm going to keep it the same as much as I can, including variables, because it's English. It looks more English then. You can read it better. Current line. Equals line dot split, and that will be just space. Yeah, I'll do. That looks okay. Yeah, I don't know how to notate that, because it says it in English. Current line equals a line split by spaces. Why have I got this here? Oh, it's that, is it? Okay. So we split the line. Interesting ideas, interesting ideas. That's not right. This is one of the problems with this, is it's not right. Well, it's not properly correct. Okay. How can I do this? No, don't do that. Don't know. Is that legal? Looks like it is. Yeah. Just like I do in the C++. Just splitting the file down a little bit. It's easier in C++ because I've got a header file to look at, but I'll go private. String. And we want to remove empty. Because that's going to happen. Oops. Wrong. No, don't stop. Do that one. And we'll take in a string array of data. How do we do this? This is going to be fun. So we'll need the array list and gather of strings. And we'll call this result. Equals a new array list, believe it or not. So how shall we do this? And why have I got that at the end? Oh, it's because we haven't got return value. Okay. Return result. At the moment it doesn't do anything, but hey ho. What? Required type string. Fine, okay. So that's the, so it needs a string to return. It's going to be result. To array. It's not going to work. Because that has to pass in res. Okay. That's not going to work. That is. And if that's going to work, then that equals a new stringy thingy. Result dot size. Yeah, that'll work. Alright, I'm happy with that. Oh, a bit snoring going on. That means it's nearly coffee time. There we go. Right, good. So I've got the start and the end. All we need now is a process in the middle. We're just going to have to go through each piece of data, see if it equals an empty string. If it doesn't, we can just add it to the result. So yeah, let's do that. 4 int index equals 0, where index is less than the data, and it's coming to me in that, so it's dot length. I've got used to that bit. Index plus plus. Oh, don't do that. Don't separate it off. It'll probably complain. Just in case. Right, inside here, if data I dot equals, remember I got this one wrong last time. I put equals equals instead of using this function. It told me off. An empty string, and it's a not we need, and it's an index that we may need. Okay. If then result dot add data index. That looks good. Check the string check the data is not equal to an empty string. That's what that does. Just pull that back a bit. All right. Add to result. Add to result the contents of the data. I think that's about all we have to do, really. Convert array back to, no, it's not array. Array list back to an array. There we go. I'm happy with that. It'll definitely take, what we're doing basically is we're taking a vector in C++. We are pushing back the data, because we don't know how big this data is going to end up being. We push back the data, but we skip anything that is empty. And then we just reformat that back to an array and throw it back out. So that the resulting array has no blank or empty strings, and it does what it says on the tin. God, I need coffee. Right, first coffee break. Sorry, but this is pretty intense stuff for me. We are writing something from scratch and improving a lot on what we had before. There you go. So you know I'm AFK. Love the music. Fred but not Bot. Bob. Fred but not Bob. Hiya. Sorry, I was just grabbing a coffee. I need these things in my life. Go back to capture. Oh my god, what am I doing in my life? You're saying. Alright. How are you doing, Fred but not Bob? I said that well, didn't I? Fred but not Bob. Welcome to the stream. I'm designing from scratch a brand new 3D engine, which is going to be a complete 3D engine this time. I'm going to do it in Java because it helps me. What was I looking for then? I don't know. Completely forgotten what I was doing, so let's just take a pause. Let's remember what I was doing. Oh right, yeah. We were removing empty strings, weren't we? Yeah, we were. Before I do that though, I'm just taking a moment to relax for the main loop and try and get my head together about where I'm going with this, because obviously it's going to go into the checks for vertexes, normals and all the rest of it as normal, which I might just copy over, but I don't want to. I don't want to copy anything over. I want to create this properly this time. Because I've already added the extra 2, or should I say the extra boolean, which makes this totally different. If you start using the booleans, that way. So yeah, we've got these booleans here that we can work with properly, and it alters the way the program can operate upon the data, and it's important because before I was just slamming an OBJ model into memory and then chucking it at the graphics card. Basically, I wasn't being careful about it at all, and the expected happened. It wasn't very good. It did the job, and I could even light it, but nah. Wait until you see the shaders. Have you ever seen my full shaders, you lot? You're gonna go nuts at the shaders. Probably use OpenGL 1.2 or something. I don't know. Depends what we need. Coffee. Alright, coffee. What's wrong, pudding? What's wrong? Are you okay there? Alright. God, that's nice. So this is a new stream today. This is a stream of Bladez drinking coffee. What do you expect on Sunday morning? Well, Sunday afternoon now. Wow. Get your beef. Get your roast beef going. It's Sunday afternoon. Oh. Right, so we are in this main line. We are reading this line, and we've just done something, and we did a read empty thingy, didn't we? Yeah, we did. Well, there's a C++ statement if I ever saw one. Is Java really a different language? It is. Doesn't have pointers. It's C++ without pointers. That's all it is. And without header files. That bit does annoy me. Yeah, that statement works alright. Right, we can check now to see if what we've got is rubbish. Or a blank line. So this will catch any blank lines or hash marks, comments. We need comments, don't we? So we'll have current line is equal to 0. Oh no. Can't say that. You'll have to do a dot length, won't we? Yeah, we will. We can use the OR. If I do an OR statement, I usually hit return, but I'm not going to because it's a 4. Current line, and it's dot equals, and that's going to be the hash key for comments in a GLSL file. We could actually print the version out, couldn't we? So not a GLSL file, a .obj file. God. I'm cross-thinking languages again. What we're gonna do, we're gonna continue. That just sends it straight back up to the while. It doesn't continue down there, it continues back to the top of the loop to come down again. So next line basically. There we go. And this is for blank lines or remarks. Yep, happy with that. Next command. Yeah, literally I do command by command. I think what I need and then I work out what command I'm going to use. Okay. So I've checked now that the string or strings that we have are not blank or blank lines or remarks. That's good news. Why is that not allowed? Oh, right, I'm putting an if statement in. Let's try that. No, it's not. There's no space. Ooh. We are going to do vertices, aren't we? Let's see now. We'll have a new vec3. May as well use it now we've got it. So what can we do with a vec3? it will be, this is where I don't like Java. It's going to be a type of float. It's going to be the value of current line 1. That's correct. Actually, no, I don't need to do that. I can just do Control D, can't I? Control D, Control D. Yeah, it works. Well, hey! I'll learn something. 2 and 3. Ah, problem. No. It's not a problem. That's wrong. Do I? No. So it's a new vector 3. I'm not sure whether these will work. Yes, it will. That'll work. That'll give me a vector 3 of 3 floats. X, Y, and Z. Check to... There we go. That's obvious, it says it itself. That's obvious. We're using a vec3. We are. If I remember rightly. Yeah, vec3, vec2, vec3, yeah. Yikes. Yeah, that'll be fun. That ends the command. What's this going to? Oh, right, it's going to that one, is it? Why is that out here? I would have thought it would be there. That's better. The lines join up. Because guess what we're going to do here? I'm still wondering why I've got two of these. Yeah, that's right. Counting my brackets at my age. when you get to my age and you start counting your brackets, you know you've got problems. Yeah, right. Yeah, that'll do. And that's going to be textures, isn't it? Texture UV coordinates. Yes, I spelt it right for once. Ah, this is easy. I like this kind of relaxed programming. I'm getting used to it. I actually used to have to do this at speed. Or was able to do it at speed. These days I can't. Hands don't work that fast. Do miss playing the guitar. Never mind. What can we do? What can we do? Oh really, it's the same code as above. I mean, we've got a good way of getting a vec3, so we may as well have the same code. And I don't think it's worth making it into a function, although you should. If you ever find yourself doing this, then you should really be making a function. Alright. Yeah, that's exactly what it should be. Check for the UV coordinates, texture UV, add a vector 2 with positions U and V. No harm in that. Well, what are we checking for next? Normals, isn't it? After textures. Normally. I've done this so many times recently that it's stupid. This is the last time I'm ever going to do this, in this language anyway. And this time is a direct copy of this one. check for normals, which we might be throwing away. Standardize your notes. So that's VN. Now we go for the face. Anybody that follows my channels or has looked at any of the videos that I've done in the past will know this inside out by now, or should do. This is going to get interesting. Alright. So what do we have? We're going to need a function. Bless you, Muppet. Thank you for joining me. And then just snotting all over the keyboard. That was absolutely fantastic. Right, let's make a function. It's private. I know that. It needs to return an OBJ index. That's for definite. We have to somehow read that OBJ index. Now the OBJ index, I don't know if you can remember from, Christmas was it? Maybe before Christmas. We were discussing how the OBJ index is constructed. And I made a big header file which included this face thing and the different variations of how it can be, or what the data could be. The data could be vertices only, vertices and textures, vertices, textures and normals. I don't think, I suppose it could be just vertices and normals as well. But it's all with a slash. So we're going to have to split it down by the slash. That's for starters. Let's do that. And then see what we're going to do with them. So the individual values will be split by a slash. Yeah. Yep, that's a word. Okay. So that's the first thing we're going to have to do. OBJ index. Do you have getters and setters? Ah, you have nothing. Fair enough. What should we have? We're going to have to detail this OBJ index now a little bit. Otherwise we can't go any further. Let's be honest. So we'll have we now know what we're storing in here. So it's a private, and they are int, these indices. So we'll have m underscore vertex index, I think. Yep. A private int for m underscore texture index, and then I'll have a private, badly done, int God, m underscore normal vertex texture and bad. Normal index. Sounds good. Alt insert. Getters and setters. Wang. Done. For now. We haven't done anything about that. Okay. Just make sure that I did get a save all on that. I just want to save all. Right, so we know this works up to this point. Now, what do I have to do? What do I have to do? We have to set it up. We're going to need a result of some time, aren't we? Some type, sorry, aren't we? So I've forgotten to do my variables, which will be an obj index of type result equals a new obj index. Is that legal? I know I didn't put a constructor in. It doesn't seem to be caring about it. What do you think, Muppet? It's okay, love. You've not done anything wrong. You're just sneezing everywhere, that's all. You feel very ill, don't you? Oh, bless you. Let's just hope this doesn't turn into pneumonia. In a cat, that's a killer. Yeah, it's okay, love. You. Oh, bless you. Sorry, time out for cat. Plus, it gives me a chance to work out how to do the result. We just put a load of getters and setters in, didn't we? So it's result dot that one. Do we really need all those big M's in there? Yeah, that does look bad. Let's alter those. I mean, I'm glad it does it for me, but the naming conventions are automatic as well. You have to remember that. I didn't even look at what it did. I think that'll look a bit better than what we had. I'll make sure it gets hold of it. Oh, that looks better. It's an int that we're after. So it's an integer dot. It's parse, isn't it? In this game? Yeah. Parse int string s. So values we used. values. And this is where we put the magic -1. There. That's the next command. There we go. This converts to an int. String yeah. So there's that infamous -1, the bit that cocks everybody up. I don't know why we don't just, we can't just put a fake value in 0 and then use the offset in the draw call. We could do that. But why bother when all you got to do is put a -1 there? Why bother with that hassle? Okay. So that would be our vertex index. We're not guaranteed any more information at this point. We've thrown away anything that wouldn't have got this far. And that would just come back with a value 0 if that wasn't found. Yeah, that'll work. Good. Works for all situations. So if, and it'll be values. Values dot length. Is it? Yeah, dot length is greater than 1. Then there's more information. So we have to check now. So if values 1, we'll check the 1 first. Dot is empty. Not constructed properly. So if it's not empty, in other words, if there's something in there, we want the value. M underscore has, this is the textures, isn't it? Yeah, textures equals true. That's how we find out whether that's true or not. And it's going to be a result. Set texture index. And it's going to be the same kind of thing, isn't it? It's going to be integer dot parse int values 1. -1. Does that look right? Yes, it does. And that's our next statement there. Texture index has been found. So that means that's converted to int. String holding the phone, yeah, and the -1, yeah. So that's just the same notes as up above. Lovely. I stay in this if statement, don't I? Yes, I do. We can do a different check for this one, can't we? If values dot length is greater than 2, which means we've got those two. M underscore has normals equals true. We found the normals. Oh god, what happened there? And it's not texture index, it's normals index. Singular. I'm happy. There you go. That's it. So read obj index. There we go. Let's save. Add. Back to here, are we? Oh my god. Going backwards and forwards all over the place. I'm writing it just as it comes up now. I know I'll get it right. I know I'll get it right. Okay, so here. So it's read obj index. Now we want the string data. And I forgot what string is. It's current line, isn't it? Yeah. No. 1. That's the first one. This isn't going to work. There's 3 of them. Yes, it will work. Problem is, what happens if some person comes along with quads? What do we do about quads? We're going to read them in. Don't like it. I don't see why we should go for quads. Should have 0, 1, 2 and 3. So that's 4 items of information. Yeah, we'll put that message in here and just stop it. Just stop it. If the current line dot length is greater than 4, system, yeah, system, oh god, dot out dot print line and it's going to be error. OBJ file is not, sorry, needs to be in triangle format, not quads. Full stop. And system. Oh, can't put it in here. Sorry. And system dot exit 99. I know what that status means. Good. That's self-explanatory. We can't continue with null data. Right. So now we can just look reading the 3. We do that. Where are you going now, Muppet? Okay. This stores them, doesn't it? In result. And we're setting them. So it's all of these are being stored in obj index. And we add it here. I'm not happy with this. This is always tricky. This is the trickiest part of the obj file. Anyone got any hints? We are adding current line 1. Which will consist of either 1, 2 or 3 numbers being set. Maybe we should give these values. No. Because we have the has. We have the we have the Boolean checks to know if they're null or not. And these always come in 3s. Always. Can they ever be more than 3? No. Alright, what's this now? That's the end of the else ifs. Oh, come on, get your spelling right. Here we go. I think that'll work. Yes, it will. That'll read it into, well, basically a structure rather than a class. But it's a class all the same. Okay. And why have I still got this lying around? What does it belong to? Oh, the try. Oh, we're getting purrs. Oh, you are a little purry cat. You're happy again. We want to close now, don't we? How did we open? Ah, wait a minute. We have something for this, don't we? We have the read line. Ah, there it is. That's it. Doesn't have to be static. Close file. File in. Pudding wants me to go and have a coffee with him. Okay. Close file, file in. Ah, different type. Buffered reader. Okay, that should be correct. Then we catch an exception. Here. Do we want to put anything on that exception? Yeah. Okay. We're done. That was it. So we now have all of the values we need. What's wrong with this? Never queried. Oh, they will be. Oh, they will be very, very soon. Now, oh, what's wrong here? Is always false when read. No, it's not. Hold on a minute. Why is that always false? And it's not the last statement in the loop. Okay. Redundant boxing. String S. I see what you mean. No, I've done it right. So I'm not quite sure what it's talking about there. Okay, any more? Oh, there's one down here. With enhanced for. Yeah, you're right. There you go. You gotta love these things, haven't you? Boo hiss. What do we have before anyway? That. Index. I prefer index. And they give us... No, I don't really like that either. Yeah, that'd work. Alright. It's just that it's cheaper than doing that for loop. Which is quite weird because the while loop is virtually the same. It's just a conditional go-to. In assembly language, all that is a label and then go-to label if that condition isn't met. Or should I say label, and then it says if condition is met, go to next label. Or return to from where you came in assembly language. So these loops can be specified in different ways and constructed in different ways, which is why it came up with the bulb. So I'll keep a while there. A while I like. That makes more sense to me. Yeah. It's just removing empty strings, isn't it? Yeah, that's okay. Alright. So that bit's okay. I'm not certain about this redundant boxing. What do you mean? Oh. I see. There's a different command for it. My bad. Wrong command chosen. There's obviously something better in Java, so it tells me about it. I love this IDE. Okay, I think we're quite happy with that bit. Or it isn't current line, it's current line 0. Because it's been split. That's why. Oh, duh. There we go. Now, what does this say? Remove braces from if statement. Why? What happens if I want them? Right, that's still a bad parsing. No, don't need to do that. Don't need to do that. Don't need to do anything on there, I don't think. I'm not reformatting the code. I don't know what it's going to do. I want my code my way. Alright. Well, we'll see how that redoes it. Done anything in there yet? Okay. So we have now started the mesh loader, and it was Pudding that was crying. So now we've started the mesh loader. I think we've actually done quite well there. Yeah, I can have a break. It's been an hour. So we'll just have a quick break, and I bet everybody comes along and says hello. Alrighty, break. Go grab a coffee, get yourselves your drinks. It's Sunday. Oh, refresh the coffee. That's good news. No chat? Okay, that's fine. Let's get back to what I'm doing then. Put that back on Stream Manager. Oh, we still have viewers. That's good. We got viewers. Well, we've done the first bit, folks. We've done the first bit. We have half of an OBJ loader. Half. Yeah. Oh, Fred, but not Bobby's now following. Oh, thank you very much. That's really appreciated. You're a star. You're a star. If you're after more information about OBJ loaders and different ways of doing it, then by all means say so in chat. If you want to ask any questions, please feel free. This is a chat channel, not a programming channel, after all, at the end of the day. So, we have stored our indexes in OBJ index, but now what we have to do is convert that data from these two things, I'm going to call them, into an index model. So let's write that out as a function. Where did I put it? Oh, I closed it, did I? Wanted to refresh it. That's fine. Oh, it's nice to get a new follow. Okay, that's refreshed it all. So we were working in here, and we're still getting these yellows. That's fine. That continues still yellow. That bothers me. Why is that the last statement in the loop? It's kind of, oh, it's it's considered the last statement in the loop because of the else's. Yeah, it's the last statement in the loop. That isn't the end of the try, no. I'm not happy with the way these braces are laid out either. What's going on here? Where's the wild brace? There. Where do you go to, little brace? There. That's what it is. It's because there's no command here. To do it, what we could do is just break the else if. And that stops the problem. But is that correct to do that? It's right in what it's saying. See what I mean? And now we get this one, do we? Replace if with switch. Why would you use a switch instead? It's not a while loop anymore, is it? The while loop. Oh, yes, it is. But now I've got an ender switch. I like this. I like this a lot. Just put an extra line in there. No, don't do that. Okay. Just want an extra line after each break. So we've got V, VT, VN, and F, all in a switch statement. That is unbelievable. I would have thought that a switch statement would have been more expensive, but it would seem that in Java it isn't. So there we go. We are now having a switch statement. Let me just put that on screen, because it's now completely changed the look of the whole thing. So that's the first part of the switch statement. If anybody wants to copy that out, now's your time. This is the new improved OBJ loader. I've never written it this way before, and that's why I'm doing it. I wanted to see where it took me, and it's taken me in a completely different way. Hope it works. I have no idea if that works. I knew the one before, the for loop, the for if, else ifs would work, but not as a switch. I've never thought of doing that way. I don't use switch statements in C++ because they're expensive. But that's interesting. That is ingenious, because it actually takes out a command by using cases. Or it only does that command once instead of every single time. I see. Yeah, it's less expensive in Java. Most definitely. That is faster in Java than it is in C++. That's what, wow. So it's been implemented properly in Java, where in C++ it was just garbage. No, I've never used it before. Because of the processing time. I'm actually happy with that. Yeah, get the F state, the case F. Break, case F, all the way down to the next break, and then end a switch, yeah. So, yeah, there you go. Copy that out. By the way, if you're ever programming a switch, make sure your cases fit on one screen. I know that I expand all of my lines out for my readability, but you don't have to. I just write my code this way because it's easier for me to read. I know which parts are variables and which parts aren't, even though it underlines them. Because I can see instantly that that's a command and that's a command and that's the variable it acts upon. And visually it separates it all off for me, so it's easy for me to work out whether a line of code or whether a command in the code will work in the way I expect it to. And if I'm not sure, I can test it. And this has a full testing suite to go with it, but I just haven't set it up. Right, we haven't done anything with our indexed model, but yeah, this is the other half. Now, if you have a look at how how I did it before, I do it all as one. So we are up to starts with F, okay? Then it takes them all out and sticks them into a vertices array, all right? And it converts everything over at this point. So it's this big converter here into arrays that we need next. So like you've got all of this rubbish coming in here for apply the index to the loaded data. You see, that's exactly what we need to do next, is all of this stuff. So from close file all the way up to what I used to put in starts with F. I used all of that as not, it's just not there. That has been replaced by 3 commands. 1, 2, 3 commands. We're just storing it all out, and as we store it, we're just mentioning to ourselves like there's booleans that turn true, maybe. So I've done it properly. And if it doesn't work, it means I know where to look. I can look at read object index to see if there's anything wrong in here. So it just makes my life easier by placing it into one set of code and one set of instructions to read through. But I don't think there's any errors in there. There might be, but I doubt it. It hasn't given me any errors. Right, we've cleared all yellow up to, what's this last one here? Variable file in initializer null is redundant. Oh. Fair enough. Take it off then. Alrighty, that's another one done. Constructor obj model is never used. Yes, it will be. What's the next one up? Assigned but never accessed. Assigned but never accessed. Never queried. Never queried, that's correct. Class obj model is never used. It will be. Right, so all of those yellows is because we haven't finished programming. They will disappear in time. But we are going to have to now do the second part. So that was the first part. And that's the constructor. Wow. Absolute wow. So when you call a constructor of an OBJ model, it will load it. Well, it'll load it into the OBJ model. So we keep the data. Bear that in mind, we haven't deleted the data. Not at this point, anyway. Because we mean to use it. Right, we now want an index model. So the index model's got to have all of those arrays. Alright. It doesn't need arrays. And the moment it's empty. Come on then. Hello, my pet. Come on, love. Welcome back. You had some kibble? Hey, did you get some kibble? Oh, bless you. I'm going to go with array lists again. Yep. That's a start. We're also going to use a little bit of trickery. nothing this time. And it's going to be Vec3, I think. And it's going to be tangents. I want more accuracy in what we're doing. And the only thing that we're missing now is the indices, which we need. And that's what this is all about. It's all about this array list here. And these are integers. There we go, integer. And that's just m underscore indices. Alright. So I am going to do a constructor of types for now. I don't know if we're going to need more than this or not, but it's not going to take anything in. So we're just going to use m positions. No, we're not. M vertices equals a new array list. M underscore texture UV equals a new, believe it or not, array list. M underscore normals. Oh, I think you're getting the idea of this now, that I'm not doing anything with this array list. Especially in the constructor, I'm not. M underscore tangents equals a new array. Ooh, a new array list. Why not? And just to make sure, we'll have some indices. Equals a new array list. Just in case we want another array list. I don't think that gaps are worth that. Can't think of much else to do. Maybe final field can be converted to a local variable. Private field m vertices is assigned but never. Yes, we know all of that because we're not even halfway close to finishing that lot. We're halfway close now to finishing this lot. Okay. Let's sort out that. Because it always says it's an error and it's not really an error. We'll need a result, won't we? And it's going to be an index model, that's obvious. So dearie me. Indexed model result. I can't see my keyboard. Equals a new index model. Okay. There we go. Now it's happy. I will need normals. Yeah. and then that should help, I think, sort it all out. This is going to be complicated. Ah, yes, I think I'm going to get an error. Oh, don't fall off, please, Muppet. Godfathers. Alright. Are you okay, love? Oh, bless. Bless him. Coffee, hash maps. This isn't gonna work. Hash maps need a key and a value. I want obj index to be a key, and for a value I want an integer. Otherwise what I'm going to do ain't gonna work. This is going to be called result index map. It's allowing me to do this, but I'm very unsure about the actual operation of it. I think we're going to maybe hack into Java a little bit, I think. Change the way that Java works. I need this to work in a certain way. Hash map, semicolon. So I've got a result index map. So we'll need the other one as well, of course. And that's just going to be integer. Integer. This is going to be the normal index map. Yeah, normal index map equals a new hash map, semicolon. Indices. Yeah, we're going to need another one. This is ridiculous. All this to correct the problem. Integer. Integer. This is what I was doing last night, working all of this lot out. Don't know if this is going to work at all, but hey ho. And now my cat's snoring. Now I'm not certain whether that obj index can be a key. Yeah, it can't be. I don't think we can just take indexed model. Sorry, obj index, which has bugger all in it. Yeah, it doesn't even have a constructor. And I'm not putting a constructor on it because it's not needed. Which means Do, 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 do. In C++, you would override the equals sign. In Java, you can't do that. Or can you? Let's override the equals sign. That one. Equals. Get rid of that. Don't care. OBJ index. I'll call it index. Equals OBJ index. Type OBJ. Object. So we're converting the object to an OBJ index so that we can make things equal to it. And what we do is we now have to return a value. Return m_vertex index is equal to index dot mVertex index. That's correct. And m_text coordinates, text index is equal to index. It's obvious what I'm doing. This is a texture one in it, yeah. And we're just doing the equals sign. Or equal to sign, should I say, or equals. Yeah, maybe. Overriding the equals sign in Java, which I bet you don't see normally. Normals, please. Those also have to equal for it to be equal. Index dot normal. Yeah, that's what I'm doing. Yeah, that's right. And that is how I want the equals to operate. I don't want it, otherwise we can't use it. Which means we can now create a hash map. But there is no hash map for OBJ index. It doesn't exist. So at override this time it's going to be the hash codes. Okay. Right. How do we do a hash code? Google it. Is the answer. You Google hash code, this is what you're going to get. Prime number, any prime number will do. And I need another prime number for the multiplier. Yep. 31 is a prime number. That'll do. Any prime numbers will do. And int result equals base. So that gives us a basic result. Alright, now we have to put in the combination. So result equals, well, it's this is what it says on the internet anyway, result times multiplier plus m underscore vertex index. We have to do another one. Result equals, well, I could just put plus equals, no. No, I won't. That'll confuse me. Multiplier. You can guess what's coming up here. That one, the texture index. Guess what's coming up on the next line? It's easy, just look it up on Google. There's nothing to it. Hash maps. I told you there's no randomness. In computers, it's just a formula. What you want to call it. Yeah, happy with that. That's a hash code. If you've never seen one before, that's a hash code. Well, according to the internet last night, that's what a hash code looked like. So today, I think it still looks like that. There are 1,000,001 hash codes, so don't comment on it. I don't care. Found a nice easy one. I'll use it. I don't know. Well, we're 3 hours in and we're writing hash codes. In another couple of hours, we'll be doing the assembly language. Get this right? I'm rewriting Java already, so it'll work properly. You can't just use anything as a hash key. It has to be something you can make equal to something, and it has to have hash codes enabled, which, as you saw when I put the override in, it wasn't. So, yeah. It has to be a hashable type. So we've made our own. This isn't exactly in the beginner's guide to Java, is it? I just realised. Never mind. Sorry, if you're a beginner, sorry. You can always ask me about it and I'll explain why. I don't mind, that's what this channel's for. You're here to learn, I hope. And so am I. Let's just say I had a few hours on Google last night. A few hours, yeah. Okay, so we've modified our obj index to accept that, so we can now safely assume that that will work. Because as soon as it sees that and that, it'll just flip its lid if you don't do the override. Why am I doing hash maps, you're probably wondering? Well, you see, do you remember that problem I showed you yesterday with duplicated faces? We are gonna sort those faces out. Give it a good smacking. We may have to average the normals out, and we may have to do something about the vertices as well, or create a new index for each and split the vertices apart. We may have to do that. So that we can do lighting properly and we can have textures placed upon our objects properly without stretching everywhere, which is bloody annoying. Well, it was to me anyway. There we go. Alright, onwards and downwards into the dark rabbit hole. What should we do next? We are going to loop through all of the indices that we have. Now remember, our indices currently are stored as an OBJ index. That's how they're stored. Oops, gone too far over. So that's what we're going to have to use. And this time I've stored them all as array lists to stop myself having problems reading the damn things back and forth and converting and getting and setting and all that kind of thing. So for int I, I'm going to use I because it's going to confuse me otherwise if I put index in here, because we're using index map as an actual thing. Size, isn't it? Array list I++. Okay. This is going to be a long what? It's I is less than, isn't it? I wonder what it's going to tell me to change it into this time. It's already there, it's already ready. Oh no, it's got an empty body, mate. Don't worry about it. Right. So we're going to have to start with the current index. So we'll have a variable that we can set to that. So that's the first thing we've got to do is get our variable that we want to work on, which is a set of variables. Well, it's it's nearly an object, but it's not quite. It's considered an object in Java, but it's not quite. It's considered a struct in C++. If you want to convert any of this. So, current. This is why I wanted I and not index. Index. That would have been a bit confusing, wouldn't it? Equals m underscore indices dot get I. The current index will be whatever is stored in that location. And that's quite a lot of information we've just pulled out. So we have a vec3 current position. Don't use position, use vertex. Dot get. This is where I struggled last time. This is where it all fell to pieces. But this time, by setting it up properly, yeah. And what do we need in there? Not a lot. Let's try that. Yep, we stored it as a vec3, so it'll get the vec3. Which one will it get? The current index. There's only one vec3. Yeah. It's just an int. So we did set it up properly. Thank God for that. I was having a nightmare there, thinking, cross-thinking it with this. So yeah, this'll work. That'll work. Right. What am I going to do about the texture coordinate and the normal? So we're going to have a current texture UV, and we'll have a vec3 current normal. Now, due to the problems I've had before, I don't know what to do with those. So I'll sort those out as we get to them. How's about that? Okay, let's start splitting this up so I can read it properly. All right. So we get the current index. Using the current index, we get the vertex index. Because that's the only one we're certain that we have. We have booleans for the other two. Do I need to set them to null? It's an interesting thought, because they might not exist. If they don't exist, we're going to have to create the little skunks. I don't know about the texture UV, but we'll have to create the normals for the lighting. Texture doesn't matter, we can have a colour for that. God help me when I introduce colour models. I probably never will on this one. I think we're only going to be using texture models from now on. I've had enough messing around. So let's set this up properly. Let's get them some values into the textures and the normals. If m underscore has textures, then current text UV will equal same as above, m underscore text UV dot get open brackets current index, isn't it? Yeah. Current index dot get texture, just like that. Else we will have our current texture equal to a vec2 of 0.0f 0.0f. Vec2 doesn't have that constructor, does it? Yes, it does. New. That's what I'm missing. Good. Sorted. Right. Onwards. I think we'll do the same for normals. Has normals. Then the current normal will equal m underscore normals dot get and it's going to be current index get normal index. No, just that. Else current normal will equal a new vec3 of 0.0f, comma 0.0f, comma 0.0f. There we go. That's simple enough. Right, we'll set our variables. We've got the indexes for each one. What's this the end of? End of the for loop. Okay. And the other one, obviously, with a return result is end of to index model, end of function. What do they call them? They don't call them functions, do they? Method. Because they're idiots. The language they use is just there to put you off. It just means the same thing. And that coffee's gone cold. Are we due another coffee break? Yes, we are. I think we've done well so far. We've just set the variables up for the conversion. Well, the main indexes for the conversion anyway. This is where it could get a bit tricky. So I'm going to get a coffee. I think I deserve it anyway. I think you need some music anyway. I need some music. Back in a mo. Grab yourselves a coffee. Oh, some good music. How are we doing? Oh, welcome to my extra viewer. You see, I do watch what's going on. I've got Stream Manager here. And where are we up to so far? We are doing well. We are doing really well at the moment. We are up to the second half of doing this lot. That's the privates. We are doing currently the 2 indexed model. So I've just dragged out the indexes. So I've got current vertex, current texture, current normal. If they don't exist, we'll just set them to zeros for obvious reasons. And now we're going to do something with them. We have to transform these into an indexed model. Now, I've already prepared the indexed model a little bit, but I don't know how much more we're going to have to write in there to get it to work. Probably, hopefully, we don't get into assembly language today. It really does bother me when I have to do that with a language. Just bypass it altogether. But Java should be able to cope with this. It does do the hash maps, and we'll set up some hash maps. So I think we should be okay. If there's anything that anybody doesn't understand, please say so, and just let me, I'll just sit back and chat with you, and we'll talk about it. And if you're asking yourselves, why is he going to such extreme measures to load an OBJ file? It's because from what I've done over the weekend, well, since last Thursday, Friday, I'm just not satisfied with the results. The results were horrible. They weren't even close to a AAA game model. I mean, if you're going to do it properly. Is my way of putting it. And a lot of research last night brought me down the avenue of splitting it all into bits and seeing if we can do it in Java without having to go into assembly language. As I am going to get a model out of this. I am determined to get a model out of this. Let's continue. Right, so we've got our 3 thingies. Right, we are going to need to use our hash map. This is where this equals sign and everything comes in, otherwise we can't do it. So we'll need an integer. This is the way of doing hash maps in Java, which I learnt last night quickly because hash maps are great. They are so much faster than linear algorithms or real-time algorithms. No, these are real-time algorithms, aren't they? It's the linear ones that can get bogged down, and linear squared. N squared. Those algorithms are useless. It'll take us a year to load the goddamn model. Let's call this the model, I don't know, vertex index. Why not? Equals whatever's in the hash map. So it will be the result index map we're going to use, is it? Yeah, I think so. Yeah, we'll use the result index map. And we're going to get from it whatever is at the key. And our key is the obj index, which is our current index. Okay, that's the key. And that will give us whatever the value is there. Which is probably, well, the first time through, it's definitely going to be null. There isn't one. But as we go, we're gonna fill it up. We'll fill it up. So obviously, we need to check whether it's null or not. If, and this is where that equal sign came in. Model vertex index is equal to null, which it will be the first time through, no matter what, then we're going to do something. What are we going to do? Not a lot, I wouldn't have thought. We can now use it. We can reuse that model vertex index, can't we? Yes, we can. And we can set it to result index map dot get something, current index. I'll have that one. Haven't we already done that? That was from current index. This is from the result index map. Right, got you. So this is another key to a different hash map this time. I'm guessing that's going to be null as well. No, don't like it. No. That should be get vertices. Do we need getters and setters? I think we do. Right, okay. Alt insert getters. Shift. Do. Okay. And it's come up with this get m thingy, hasn't it? Yeah. That's okay. But we are going to need getters. It's going to be null. It's for the tangents now. That's going to help a lot. Oh, this is not going to look nice. Oh well. We'll see what happens. I'm going to try and type it in. Choose one. Choose one. Choose any of them. I'll have you. You're the main one. The one that we have to have, so we'll choose you. And we'll just take your size, mate. If you don't mind. Which to begin with will be nothing. Right, we can start setting up these hash maps here. It's the result index map that I'm interested in, isn't it? Yeah, it is. It's this one here. It looks like that's what I'm using for the checks. So we'll because it's a null, we'll fill it in. We'll add it into our result index map. So it's result index map. Oh, that didn't. Tab, thank you. Index map. Put. What are we going to put in it? We are going to put in a key, which will be our current index. That's what we'll set it up for, to be a key. That's what we're looking for, remember here. So that's what we're going to use for our key. And for the value, we'll use this model vertex index. Why? Because that will tell us what spot or place in the model vertex the model vertex index is holding the position that we are going to use to store things, or the placement of the like a pointer to a place where we're going to be storing things. I think that's the best way I can put it. So we'll use the model vertex index for this. So that's what we'll store in there. And as you can see, that's where we're pulling it out of there as well. So we'll update it so it's correct. Right. So that'll be the correct details there. Good. So that's that hash map sorted out. Now we need to start sorting out everything else. So we've got result. What can we do here? Get vertices. And we need to add the current position. Current vertex. After that, so now we've got the current vertex in the correct place. Alright, what do we need next? We need the result of the textures next. Will do. And we'll add that. And that will be current texture. This is making sense. These are all these ones here that we set up for current. And result, the last one we have to do is normals, of course. Dot get normals. We'll have to do the indices as well, won't we? Yes, we will. Add whatever the current indice is. Whoops, did it wrong. Current index. No. Normal. Don't do that. I just got distracted. Might not have normals. Might not have. We might be leaving normals as a null pointer. Oh, yes. We're going to calculate the normals. So that is an automatic. If has normals. That's it, really. I think that's the end of that statement. Yeah, it's on one screen. So if it's null, we add everything and we update our hash map. If it's not null, we're going to have to do the same damn thing for the normals. That's going to be null the first time. And we need to use that normal index map. So this all is derived around the first map, isn't it? Result index map. Now we need the normal index map, and then we'll need the index map. So we need to sort the normals out. because the normals were cocked up by overwriting, which is why we need the hash map. So I'm going to use the same kind of technique, aren't I? Alright, fine. It'll be an integer again. This time we're going to use the normal. Well, we'll create a new variable, don't we? So normal. Vertex model index. Yeah. We're safe. Right. I want consistency. Because now I want the normal model index. This is what I want to call it. Normal model index. I want the naming conventions to be the same. And this one's going to check the normal index map. And we're going to do it in exactly the same way. So it's a .get. And what do we want to get today? Blades. Same thing, really. I think. Nearly. I think I've made a mistake. Maybe not. Let's try it. Current index dot I'll need the vertex index. That's an obj index. Oh yes, I got you now. That's an obj index. Obj index. Int. Yeah. That'll provide us with an int. Yeah. Alright, I'm happy with that now. As long as I'm getting what I know what I'm getting, I'm quite happy. Again, first time round, it will be a null. Or a 0, is it? Null. No, it is a null. Null return. Yes, if that's equal to null, yeah. Okay, let's try that. See if it looks right. If normal model normal model index is equal to null, which it will be the first pass. And what's going to happen? The same as up here. We need to update the map, and we need to set a few things. This is going to be funny. Okay. Normal model index equals the normal model and we just need the size. And vertices is a thing that we know we have, so that's the one we're checking against. Makes sense. Now we are going to have to update the map, just the same as it was before. So this is the normal index map we're checking, isn't it? Yeah. So we will need to put something in that position, so that next time we meet that position, it won't be null. Yeah. Let's see what we can put in there. Let's try and put the right information in there. It's just the index we need, isn't it? Have I made mistakes? I keep thinking of making mistakes here. Current index, comma, vertex model index. So we're going to use, not quite the same, we're going to use this part here, I think. Yeah. Current, I got nothing. Okay. Current index, God knows what happens there. Dot. Yeah, we use the same one. Let's use the same key, otherwise we can't look it up again. And now we just need the normal, don't we? Which would be the normal model index. Yeah, that's right. Yeah, that's right. Now we can set everything for the normal model. Normal model. Get vertices. Dot add. And that's current position. Current vertex. Yeah, it's looking good, this. Hope you're all following along at home. As I'm trying to drag this out of my tiny little brain. So we'll add the current position into the normal model. Yes, meow. This time we want to get the texture, please. And we'll add the current texture. We should really be separating these up and doing it properly. My bad. Otherwise I can't read them back and check them. Okay, that completes that command. Good. Normal model. Don't get normals, I suppose. Dot add. this will be... Yeah, we can just use current normal for that one. And we're going to make a new one. What we're going to get this time, get tangents. Add. Yeah, we'll do that one. And what the hell are we going to put in here? Vec3. Because we haven't got these yet. And I'm just going to have that as 0.0f, comma, 0.0f. Very original, very inspiring. Because I can't really think of anything to put in there. Are we done? Yeah, we're done. Right. We're into the finals. The finals. No, yeah. Right, let's do the finals first and get rid of this loop. And then we can start worrying about normals and tangents. Thank you, Muppet. Very kind of you. At least you didn't sneeze all over the TV screen. There is that side of it. It's awesome being here. Okay. Let's see what we're doing here. Result dot. Indices, please. We haven't sorted the indices out. We better add something into there, otherwise we won't have any. It's got vertex model index. Ah, yes, because we changed it round. Yep, it's that one. So that will take care of our indices, because we need to track the vertices. All our indices track vertices. So vertices that give well, the order that the other buffers are in will be the order that they get picked up in. Index-wise, for each vertex. So the indices always point to the vertex buffer. The vertex buffer then keeps track of the... Sorry. Indices points to the vertex buffer, the textures buffer and the normals buffer, and goes along them at vec3 speed, vec2 speed and vec3 speed. And they all have to be in the correct order. And that should put all the indexes in the correct order. Up to a point. Having the indexes in the correct order is one thing. So our normal model. Not the result, our normal model. We have to keep track of that as well. We need to add to that as well. We should have put a semicolon after it. Yeah. That one. Vertex model index, normal model index, that's correct, yep. And now we've just got our index map to fill in, which is the last of the hash maps. So that's going to be put the current information in there, which is vertex, model index, comma, whatever we've just put in the other two, really. The normal model index, we'll store those two in that hash map so we can look them up and compare. That's the end of that. Last command is the hash map, the index hash map. Now comes the funny business, or some funny business anyway. Alright, so we better check for does not have normals. We'll do normals first, why not? Don't think it really matters which way around we do this. So for we've left that for loop, haven't we? Yeah. Int I equals 0, comma I is less than result dot get vertices size. I should do it. Well, I hope it does it. Does that look right? Yeah. So result dot get normals dot add. To take these from the normal model. Yeah. I will need the index for that plate. Ah. Maybe I assumed too much there. We need to be able to get the index map. Follow it through. Normal model is an integer. No, it's not. We've got the getters. So I should be able to get it's an indexed model. it. Damn it, damn it, damn it. Get normals will result in an array list. Of vec3s. And we need one of those vec3s. Or a set of those vec3s. Why won't it let me do it? It'll allow me to get the normals. Well, then it won't dot. Oh, it will dot. Yes, get index, that's what I want. I want that index from the index map. Index map, yes. Thank you. Does work. Jesus. Alright, what are we doing with this index map? We're going to have to get again, aren't we? Dot get object key. Thank you. And that's where we put I. Is that correct? Yes. No. We've still got a problem with result. Expected a semicolon? Yes, you did. Well done. Okay, so we are adding to the normals whatever is in the index map. Jesus. I knew it was going to get complicated, but diving down a rabbit hole. Well, we've got it there. An integer. Array list. So we get array list number. We're adding to the array list the index. That'll give us an index model. Jesus Christ. That's it. I'm glad you're all following along at home. If anybody wants to query any of this and ask me to explain it in any better terminology than English, please say so, because I think I'm talking Swahili right now. Or I'm thinking Swahili. That's all we have to do if it hasn't got normals. We just have to fill it full of something. Right, okay. Get out of there. Right, what do we have to do next? Let's see now. What can we do? What kind of Swahili can I come up with next? Believe me, that's what it feels like. Yes, I did pass every maths exam that I ever took. Don't ask me how. So, dummy if not normals. Right, we need to do the normal model. It needs to calculate tangents would be nice. What do you mean it doesn't exist? I know it doesn't exist. So that's going to be our next part. I want the tangents. If you'll let me go. Oh, it's not there, is it? It's here. We'll have to do it here. What did I just put? That's going to be public, isn't it? There we go. How do you calculate tangents, everybody? We have fun. We have fun in the sun to calculate tangents. Right, where do we start this one? We'll start it with a for loop, why not? As I always do. I'm going to use int I because of indexes hanging around, or indices. So int I we'll use. How big does it need to be? Well, it has to be for all of the indices, doesn't it? I is less than indices. And we'll just need the dot size of that, I suppose. That'll do. That'll give us a nice big for loop. So that's going to be calculate tangents main for loop. Yeah, I'm already getting ready for it being going off screen. What, Pudding? What do you want? What time are we on? Oh. Why do you want food? I know you want food, but why aren't you eating your biscuits? What's wrong, love? Okay. I've got a crying cat, so I'm going to just give him some attention and find out what he wants. Make a coffee, I suppose. This one's warm, so... Damn it. I'm just about to think about how to calculate a tangent. Why is that gone red anyway? I don't know. Let's have a look here. Give you some music. Ricochet! Dance! Or grab yourselves a coffee, depending on you. Come on, Pudding, what do you want, love? When do you want, love? No, it's not me. Oh, that's food for him sorted out. Bless his little cotton socks. He's older than me. What do we want to do here? We want to swap that out. Yeah, I remember now. Get you back onto managing the Twitch, Mr. Stream Manager. How are we doing anyway? We're up to 4 hours 24 minutes. Oh, that's not bad. We've got viewers, so hello to you and thank you for tuning in. It is appreciated, actually. It really is. I wish I could grow the channel more and have more people help out with the projects and become proper programmers and stuff like that, and see how programming really works in the real world, especially when you're designing an OBJ loader for a 3D engine, a full 3D engine, which I hope to complete within 6 months. I'll give myself till Christmas. I want this complete for Christmas. It's going to be my Christmas present to myself. Is a complete 3D engine. And if you don't like typing, then I suppose you could get in touch with me. But I mean, I've only just started it today, so there's not really that much code yet. I mean, I'm only up to calculating tangents for the OBJ model. Because the OBJ models don't give the tangents. And when you want to do good lighting, you need this kind of stuff. Because the tangents are important, or will become important later on. How do I know this? From 3 years of designing OBJ loaders. For different systems. Because every single system wants it in a different way. Well, I want mine this way. This is my system. It's the first time I've ever designed any kind of 3D engine for myself. Normally, I just get somebody else's code and they say, can you please put me an OBJ loader into this? And I say, no, I'll write you an OBJ converter and then I'll put the actual loader into there. And they'll go, why? Because it'll be bloody faster. So all of this code that I'm writing now will be ripped out of here eventually and placed into a converter. There you go. And I found some nice bubbly liquid here. It's not me normal burpy liquid, it's lemon and lime. Nice. Yeah, that is nice. Right, onwards and downwards. Oh, inbox. Oh, that's just notifying me that Fred but not Bob is now following me. And that is seriously appreciated. I'm going to keep that in my inbox for now because I appreciate that. That's nice. And if you want my email address, by the way, it's fraser.sharp@virginmedia.com. That's the one to use. If you don't use that, I won't reply. Should say it's somewhere on Twitch. Maybe I should look at that and update it properly. Anyway, why's that gone red? Jesus. happy with what I'm thinking. We need some indices. Let's get some indices. Let's get 3 indices. Yeah. We might need an XYZ for this somewhere, I think. Oh well, we'll find out. I think this is the way I normally do it. Yeah, that'll get a 0, 1. Yeah, that'll be right. We'll have a third one as well. I plus 2. Okay. Looks good. So if we've got our indices, we need to do the edges. Ironically, I'm going to do this properly. This is the stuff you don't normally see on my channel. This is the real stuff. So vec3. Edge 1. We'll make that equal to something. Maybe something like vertices might help. And we'll get... Who shall we get today? I1. Index 1. Yeah, you'll do. Dot. Can we subset this? Subtract minus. What is index 1? It's an int. Vec3. God damn you, Java. Why can't you have maths libraries? conjugates and setters. I don't understand why it's done that for all of these and it's done that for that one. Ah, well. Actually, I'll put it towards the bottom. And what we're going to have, public vec3 sub. That's going to be a public vec3. And it's just going to be a sub. Vec3 right. God, I remember doing these. Oh well. Never mind, so I'll have to write them again. And what we're going to do, we are going to return a new vec3 that goes somewhere along the lines of this. M underscore x minus right dot get x comma. This is difficult stuff, this. M underscore y minus right dot get my. Yeah, m underscore z minus right dot get z. That's it, isn't it? We have to be careful here because there are two subtraction methods for a vec3. Which one shall I be using? I wonder. I need a vec3 right. Let's find ourselves a vec3 right. Oh god, what was I doing? Index model. La 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 la. I'm trying to remember how to do it. So it's I1, so index 1 minus index 0 to get the first line edge. So it's going to be m underscore vertices. Yeah, that's right. So if that's edge 1, guess what, peeps? We're going to do edge 2. So it's just the same. except it's going to be edge 2 gets index 2, and I bet we're going to minus off it index 0. I may as well. You can choose either, actually, doesn't matter. But if you choose index 1 here, you have to remember that index 1 then becomes the center of the 2, or the join of the 2. So I may as well use index 0. Doesn't matter which. As long as you got 2. Because now we've got to get the delta values for our textures. So we are going to have float delta, and it's going to be the U part 1 equals, I'll just do that, control D. We're going to have the UV of 1 and the UV of 2. Right, what's UV1 going to be? A U1. Oh, we need the text code, don't we? Right, we'll have index 1. Again, we're going to minus off. Dot get it's an int. Yeah, you can't do that. Can't do that, so we'll have to do it here. Dot get. What do we want? X. I'll take X. Minus M underscore text UVs dot get index 0 again we're using. And we'll have to get from that either the X coordinate or the Y coordinate. I think it's the X coordinate. Yeah. Dot get. I don't think I really like that M in front of dot the get thingy. I don't like it at all. Sorry Vec3, but I don't like it. Can I rename it? Yes, we can. I just want to alter it by that, and that. Go. That didn't seem to work. Bugger. Oh hell. Oh well, that's never use, that doesn't matter. So refactor didn't work. It's the only way I can do it. Interesting. Oops. Okay, just stuff it. Let's just get these done. It's going to break the code, but I don't care. Get Z, isn't it? So, get Z. Just goes to show, doing automatics isn't always the best thing to do. Okay. File, save all, refactor. Doesn't matter. According to that. I've got no red. And it's still using it. I don't understand. I don't think their refactoring is fully working properly. No idea what makes me think that. This is wrong now. Surely. Where's get MX coming from? These have never been used. That one has. That's getX. May as well do these whilst I'm here. Distracted from what I'm trying to do, as usual. Alright. Come on, things should start breaking now. Yeah, thank you. It's now realised. I didn't realise it was a vec2, sorry. My bad. Well, it should be anyway. It's textures, isn't it? I'm dealing with textures here. Stupid me. So I went and modified the wrong goddamn thing. Object index. No red. Object model. 2 yellows have appeared. That went back to a for loop. Oh no. Something I can alter later anyway. But no red. I'm sure I used it. No, I just used the... Yeah. Not used in there. Definitely not used in there. Alright. So that's the first one. Well, the second one's virtually the same, isn't it? Well, they're all virtually the same. So what have we got? Delta V1. Get index 1. Yeah. And it's the Y values, is it, that we need now? Yeah, get Ys. Yeah, we just need the Y values. That's all. Changes. We do the Y values separately, of course. Oh, thank you, Muppet. That's very kind of you to do that. That was beautifully nice. Right, so this is going to be index 2. Again, the second one you can change to 1, but I'm going to keep it as 0. And this is X and Y, isn't it? X. And this is the same, but it's for the Ys. And it's index 2. So that's them all covered. And it looks better. So that's 1, 2, 2. Yeah. Looking good. Can't call it result. We need the result of all of that. We have a problem with the 0 division as well. No, I think we can get back. Well, I think we'll be alright. Oh, God, these things. So how is everybody else doing today? I mean, it's a nice lazy Sunday. What's happening in the outside world? Have we still got a virus thing going on? I think we have. I haven't had any telephone calls or messages saying that it's stopped. So I gather that it's still happening. Which is a shame. Because it means nobody comes to visit. But hey ho, I've got the cats. They look after me. Divisor? Because that's what it is. It's the thing you divide by. Is delta U1. Oh dear. We've got brackets. Can we get rid of that bracket? So it's delta U1 multiplied by delta V2. The opposite one, which is a y. So it's x times y minus the other two things. So that's delta u 2 minus delta v1. Very simple. That's your divisor. No, it's in multiplication. It's not a negative. Get it right, Blades. Yep, that'll do. That'll be a divisor. What do we need the divisor for? We need it for a ternary. Float. Just any float, really. F. Doesn't matter what it's called. Factor, float, whatever you want to call it. Call it F. Call it factor. Makes it factor equals true or false, really. Dividend. Why is it a float and not a... Ah, right, yeah. Just thinking of Boolean then for a minute. Yeah, we'll use a divisor. And we'll make it equal to 0. Can have that true or false. So it's going to be that 0 or 0.0f for 1.0f divided by the divisor. Yeah. God, that's complicated. So if it's equal to 0, you get 0. If it's not equal to 0, you get 1 divided by the divisor. I hate doing those lines. I don't normally use them, but it saves a lot of, well, a messy if statement, I suppose. Right, finally, let's make a tangent. Yay! No point naught f. Start it off at zeros, I suppose. 0.0f. 0.0f. Will that do? Yeah. It will do. So we're finally getting the tangent. Oh, God, I remember this from bloody school. I'm not joking. As soon as I saw the equation, I knew what the equation was. It was an awful feeling. It was like, oh my God, 40 years ago I was sat in a classroom doing this. That gives away my age. So yeah, I was really happy to see this formula again. Here we go. Let's do the tangent. Tangent dot set x. Oh my God. Why have I got an extra, you damn muppet? Thank you. Set x to f actor multiplied by delta. It's the same, isn't it? No, it's reversed. V2. Yeah. Multiplied by edge 1 get x. That one. Minus delta v1. We used v2, so we've got to go to v1 now. Times edge 2. Did I use edge 1? Yeah, edge 2, that's right. Get x. And that's it. Not happy about this line being like that. That closes a factor. Yeah, that works as a statement. Wow. I'm going to have fun doing this one, aren't I? We need the x, y, and the z. So that's x. Done. So we're going to be setting the x, the y, and if you don't know this formula, I would advise you to look it up, and the z, because it's pretty complicated rubbish. But you can simplify it down, really. So now we want to get edge 1 y. So it's pretty easy, really. It's not that complicated compared to the other stuff that I'll get into later. This is child's play. I think that's right. v2 times edge 1 get y. v1 times get y on edge 2. So as you can see, it's not as complicated as you thought. All you have to do is change these ones over. So that's now a z. Oh, we can't get z. Edge 2. That's a vec 3 subtracted by a vec 3. It is a vec 3. It says it's a vec 3. Why can't I get the z on a vec 3? That's why. Spelling mistake. But I only did 2 subtractions. Careful, don't get this wrong. Edge 1 sub index 0. Edge 2, oh yeah, sorry. No, we just need 2 edges. That's why there's not a third one. There we go, it works now. Check the code is right. XYZ, XYZ. Yeah. 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 Way too easy. Way too easy. We need harder equations. By Jove, we'll get some. I want more maths. Right, let's set it up now. We should now be getting very, very close to the final tangent. So let's do it. Let's try and do it. Let's go for that M tangents. M tangents. Dun dun dun. Dot. Get. It's going to be index 0. Dot set. Which one? So vec3. I've got getters. Guess what, peeps? We ain't got no setters. Dun 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 dun. Alt insert. Shift down 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 down. Ding. We have now. So let's just go down a bit. Set to text charge. Da 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 dun 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 dun. Normals. Dun, 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 dun. Tangents. Yay! That's what I want. And indices. Maybe now we can do it. Yay! Look at that. Index 0 dot set. No. No, 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 no. It still hasn't come up. Is a vec3 get index 0, which is an int. That will return a get. That will return a vec3. Dum da dum dum dum. Public float. No. Public void. Set. Open brackets. And it takes in a vec3. Vector. hold on a minute. I've got to produce a vec3. How shall I do that? I know half the way around it. I need a maths library to look at. All I want to do is set, isn't it? I thought we got that free. Or am I missing something completely? Or I think I'm missing something completely. Java doesn't act the same way. I've got to be careful. Oh, thank you. Alright, we'll do it the proper way. First of all, we have to create a different set function. So it's float x, comma, float y, comma, float z. So that's the first set function. And it's basically copy. That. Except you can take that off each one. There we go. So that's your first part, I think. It's not a void. And that is return this. Oops. Do it properly. Thank you. Now I can do the second one. And the second one is public vec3. Do it properly this time. Set. And this is vec3 right. Yeah. That's better. So all we do is we set let's have a look. Right get x, comma, Interesting. Oh, there's a comma there, that's why. Right. Dot get y. Comma. Right. Get z. Go back to the beginning now. Yeah, that's right. Good. We set all of that lot, which is correct, and then we just return this. Magic. The magic and beauty of computers today. Java's is a really relaxed language, I'm finding. I don't get annoyed. Well, when I'm doing work on C++, I get very annoyed at IntelliSense. Whereas here, it's like it's helping me out. It's rather good. It's like this set here. Return value of the method is never used. Well, not yet it isn't. As we've only just written it. Right. Back to here. I can now do dot set. Yay. With options. Isn't that nice? Hey, isn't that nice? What the hell am I doing? I've forgotten again. Tangents. I was going off at a tangent for a minute then in my thoughts. That was a joke. Oh my god, I'm joking now. That's it. If I start joking on a Sunday, I may as well just stop right now and start playing games. Go and play World of Warships and shoot some ships. That's what I should be doing right now. Not this. Not tangents. So we've got index 0. We are going to set. Let's do this properly. Right, that's better. M tangents. And that is going to be whatever it currently is, dot. So we have to keep whatever we've got. We can't just overwrite it. So that's easy enough. Get index 0. But we do want to add to it. Back to vec3. And we want to add a vec3. We don't have add. So public. Is it vec3? I think it is. Oh dear me. Yeah. Vec3 right. That's the correct one I want. And what we're going to do with this one. We are going to do the following, something or other. We need to add it, don't we? Yeah, we'll do it the same way we did the other one. Return a new vec3. God, these math things are so easy. Especially when you do them like this. And, ooh. Sorry. Starting to make mistakes. Oh dear. So it's... What am I doing? It's just this. Why am I even typing this? It's that. I didn't spot that one. There we go. That's how you add. Is that correct? Yeah. Yeah, I'll take that. Dot add. This is an amazing way of doing things, isn't it? Basically, you write the code as you generate it. I don't want to do another full maths library unless I have to. I probably will end up writing a full maths library, but that's not the point. Really, is it? So we can add the tangent at long last. Yay! Is that correct? Take your first tangent and set it to the first tangent plus whatever tangent you've calculated. At index 0. We have to do that 3 times. The tangent's the same. So obviously we have to do it 3 times. There has to be 3 tangents, one for each vertex. 1, 2, 3. There you go. We've got 3 tangents now. It's going to be index 0, index 1, index 2. That's what we decided we were doing. And have to duplicate index 1. There we go, index 2. That's it. And that means we should be coming to the end of that section. Which, if I'm right, was the major for loop, wasn't it? Yeah, calculate tangents main loop. I think we've done it. We have. So really all we need to do is finish up and make sure our tangents are all in the right place. So now we've calculated them, let's use them. Is that the edge? Oh, it is. Where does the edge go to? Yeah, a final, that's okay. So this is all class stuff. So that's the end of the main loop. Yay. what's next? 4. Yes, folks, we've done it again, haven't we? Int I equals 0. God, why do we keep doing this to ourselves? I has got to be less than m tangent size this time. As it was last time, I guess. Or was it vertex size last time? Didn't we measure this against vertices last time? I hope we did. No, we're still using... Oh, we indicized it. That's okay, that's fine. Well, now we want to do the tangents themselves. We want to make sure... We have to update them all. I++. Alright, there's our for loop. How do we update them all? We update them all by... Oh crap, normalizing them. Alright, fair enough. We'll do that. Let's see if we can get the full command in first. It was bad enough working out this one with the add-in. Now we've got something very similar with the normalizing. So here we go. It's going to be m_tangents get I. What do we want to do? We get I. Oops, we don't want to duplicate it. We just want to return that. And we want to return that. Alright, so once we get I, we want to set, which we do have. Now comes the fun part. Because it's m tangents, get I. This isn't needed, I just realised. This can be done in the shader. But we're doing it here. Dot. And we haven't got it, have we? No. We need to normalize it. Which means the tangent direction will represent a direction rather than direction plus magnitude. So by normalizing it, we make the magnitude 1. So that we can use it in calculations, and especially in dot product calculations within the shaders, to help us out do certain things, very spectacular things. So yes, we need normalized, and we need it on vec3 again. Okay, good, I left a space for it. Not that I knew it was coming up. So how do we normalize a vector? Pythagoras is the answer. So how many different ways can we do this? We'll just do one. Yeah, we'll do it like we've done before. We're just doing one at a time. So we need 2 functions to do this. The first one being length of a vector. So let's do that one first, because that's just a float. So that's a public float length, which we don't have yet. And this is a straightforward return value. I'll cast it to a float because it involves maths. And it will be math. And it's going to be dot the square root. It's just Pythagoras, that's all. Don't worry about it. It's not a major issue. It's just a square root of everything squared. So it's m underscore x times m underscore x, comma. Well, I think you can guess what we're doing now. M underscore y times m underscore y, comma. M underscore z times m underscore z. Did I not put new? No, it's just a float. What did I do wrong? Why is that not correct? It is correct. I wonder if it's just Java doesn't understand what the hell I'm trying to do. Because if you take the float away, it's a double. Everything's in the right place. Something a bit weird about this. What's going on? Expected 1 argument, but found 3. Oh. Damn it, it's Pythagoras, dummy. Plus. Got it. Sorted. So that's the length. It's a square root of mx squared plus y squared plus z squared. I think we all know that that is the size or something of a triangle, but it also is the length of a vector. So now we've got the length of a vector, we can actually do the next bit, which is what I've forgotten. What are we doing now? We're doing normalized thingy. Right, okay. Alright. We get to dot and cross products later, don't you worry. If you want me to do them now, we'll do them now, but nobody's requesting those, I don't think, on chat, so I'm not going to do them now. I'm just doing them as I get to them. Normalized, the American way. And we will return a vec3. How's about that? We'll be kind to it. So, to normalize, or normalized, to make something normalized, we have to divide each of the components of the vector by its length, which is why we needed the length. So, float length equals length. There we go. That was simple. And now we can just return a new vector. Return a new vec3 semicolon comprised of the following components. And each component is easy. It's just m underscore x. We're going to divide that by the length to make it a unit of 1. No, I think that's right. M underscore Y divided by length. M underscore Z divided by length. Great stuff. Great stuff, great stuff, great stuff. That's it. Not very complicated stuff, but that will create a vector with a unit length of 1. Which is very, very important when doing very tricky maths calculations, not having to work out the length of them and divide the results out and do this, that, and do the other and get, just makes for absolute pain. So we're just normalising it. And it's normalised. There we go. That closes off properly. That closes off properly. That closes off properly. That's everything done. That's it. We are done. We are done ski on tangents. So we now have the full formula for creating a tangent in one huge for loop, and we even bother at the end of it to normalise the damn things. I just feel like a hero. Ah, dear. So we can now calculate tangents. Which brings us back to where we probably were in the OBJ model. Ah, dear. Don't need you. Back to here. Oh, it lights up. Dun dun dun. Fantastic. We did good. Right, so after you calculate the tangents, what do we need to do? Oh god. Another for loop. We have to go through all of the vertices and add those tangents in. Yep, we do. We better now we've calculated and we may as well put them in. So 4. Yeah, go on then. Int I equals 0. Semicolon. We're gonna go through the vertices. Yeah, I think we are. So I is less than result dot vertices size. Yeah, that'll do it. I plus plus. That'll do it nicely. I like it when it's like that. Just works out nicely. Here we go, folks. Fun time. Result dot get tangents, which is the only one we haven't done so far. Dot add. Fun time. How do we add them? Well, they're in the normal model. That's where we put them. You see, normal model, calculate tangents, so normal model, let's get them out. Get tangents. But we also need to do this with the correct index. Might help. So we've got another get here. And that is to get from the index map the current index that we're looking for. So we'll have to use the index map for that. That's why we need all these damn hash maps. Dot get I for the key. That'll work. It'll work even better if I separate that out so I can bloody read it properly. Sorry, but I should really wear glasses, but I've got a 50-inch screen, so I'm not supposed to need to. But the text I still find small on it. I mean, if you think it's bad at your end, you should try it from here with my eyes. And cats being in the way. Pudding, it's half an hour now to when you get your food. Okay. I'll just slow down a bit. So that'll put our tangents into the result. And now we can return the result, can we? Can we actually return a result at this point? 1 second, there might be a problem. Texture coordinates, 1 second. Can't do that. No, that part of the equations and stuff can get lost. We're not doing that. We can just return the result. And we can be happy that we've done it properly. End of method. We've reached it. Wow. That was a journey. Wow, what a method. As they say in the Java world. Where does it start? 2 index model, it starts here and we've still got this to get through. What's happening here? Method to indexed model is never used. Well, no, we haven't even written that part to use it. The for loop can be replaced by an enhanced for loop. For each current index in indices, God, I hate this idea. It's rather good. Damn, that works. What's this now? Yeah, that's okay. Alright, what's going on up here? Maybe final. You're quite right, actually, they can. But can we hold off on that until I find out if we need to use them anywhere else? Or set them from anywhere else, because then they won't be final. Yeah, that's okay. Bloody hell. I have no idea on how to program in Java. Does it show? No, I'm happy with the result there. I'm happy with the file. And I'm more than happy for it to do that. Wow, we have an OBJ loader. Although it doesn't look like it. We have now created an indexed model. So what do we do with an indexed model when it's at home? That's the question, isn't it? Right, let's just make sure our obj index is actually fine. It is. We've got one problem with it. What? Equal should check the class of its parameter. It does. We just changed the class. What do you say? Oh. There we go. Sorted. There you go. It's put a warning on it. I'm not changing that. I know it's a hack. But if Java can't do it, we can. It's not my fault that it doesn't make all its objects hashable, which is completely sensible thing to do for a language, by the way. It's not something that's missing out of the language. The language is correct. It's just that we want to use it slightly differently this time to make a hash map, which we have successfully done, it would seem. Right, so we've got a tick on obj index. Look, top right hand corner, you get a little green tick. Analysis completed, no problems found, and that's because we did that. On the index model, ooh, we still got some stuff here. Feel free, I don't care. What do we got down here? Things that haven't been used. Is that it? Never used. So what you're saying is, if I take this lot here and I go Alt/, doesn't work. Okay. Control/, that does work. Right, what's the stuff at the top? Finals, isn't it? You know something? I think I'll keep those open for use for now. They're not harming anybody, but it's just wasted code, I suppose. Control/. I'm not sure if you should keep it or not, because when it compiles in Java, it's supposed to throw it away anyway. It's not up to the user of the IDE to monitor. I suppose it's bloat, isn't it? Code bloat. Which is why I didn't want to set up, write out a maths library at the start, because that's what I normally do. And it's why I haven't tested the maths library this time, because I've written it that many damn times and know it backward. Okay, I think I'm happy with that. How's about you lot? Are you lot happy? I'm happy. Cats are happy. They're not crying at me. Where do we go from here? Okay. So we've just done that lot. I don't want to do resources yet. I think we could go onto the mesh itself now and design a mesh. That's rendering. That comes under rendering as well. Oh, wait a minute. Build. Run. No crash. So we must have done something right. Okay, let's have a look for a mesh. Class. There you go. Good name for a class. Good name for a class. Mesh. This is obviously the one, the class that puts it all together, I would think, for the loading of the mesh and everything. So, really need to decide what I'm going to put in here. We are going to need another hash map. Yay! But that will be for later. For now, you're going to really love the mesh. The only thing that I could think of when I decided to do it like this was the mesh would hold. You're going to love this. Done. That's it. Though that's the set of variables I need to hold in the mesh. All I need to know is its damn file name. Everything else is elsewhere. All those variables we need to load it are all in obj model, obj index, and index model. That now contains all the data we require for OpenGL, and all in the correct order, with tangents this time. Which will make our lighting awesome. Right, so what we're going to need, we're going to need a public mesh constructor, and it's going to take a string file name. And this is really going to hurt you a lot to do this, because it's going to be this dot file name equals file name. Anything else we need in this constructor? Yeah, the resources, but we haven't done that. We're going to need to do a resource package due to the fact that meshes are going to be created and thrown away on the fly literally on the fly. You shoot a bullet, you need a bullet mesh. It gets created when you shoot it, a bullet gets whizzed through the air, and then when it's no longer needed, it gets deleted. Java will not delete. You have no delete function in Java. There's no pointers. You can't delete the damn thing. So yes, we will probably be overriding Java a little touch there, I guess. Unfortunate side effect of the language, but I don't care. If I want to delete something, I'll bloody well delete it, whether it likes it or not. Stuff your garbage collection system. I hate the damn things. They do come in useful to protect you from massive memory leakage, but seriously? Does it actually wipe stuff off the graphics card? Probably not. Not until you exit the whole program anyway. But you don't want models that you're not using on, like from the last level of the game still on your graphics card when you've got a new set of models for the new level of the game on your graphics card. It just doesn't make sense. That's just a complete waste of memory unless you get reverted to level 1 at the end of level 2. And you want to keep them there, which you shouldn't do at any rate. Alright. What kind of functions are we going to need? Yeah, that's a constructor. That's it, folks. Do you think I'll need getters and setters? That was a joke, by the way. I was being sarcastic. Grief. No, but I'll need a whole lot more. Like a second constructor. I'm doing it properly, remember? Not the easy way. What happens if we don't want to use a file? What happens if I want to test it by putting in the vertices of a triangle and draw a triangle to the screen? Because I'm an idiot. I'm probably going to do that, actually. What we would need is something like a constructor that goes along the lines that, yes, you can have more than one constructor, folks. Yeah. Just run into a problem. And it's called vertex. Where did we put vertex in here? Have we actually put it in the renderer? Or not? Yes, we have. It's there. Okay then. So be it. We now have vertex. I'll think about that in a minute. Because all I wanted to do here was put in vertex. Comma. And that would be vertices. They know it's food time. The cats are gathering. Oops, did I put a comma there as well? Daft. Daft me. I am starting to make mistakes. Mind you, can you blame me? After what I've just been through with tangents. Indices. We'll do this one and then that's it, I think. Because I'm knackered. We are going to need more than this. So, this. vertices, comma, indices, comma, faults. We don't have them. Normals. And we don't have that functionality yet. So I'll just take that out for a second. Make sure this builds. We've got no errors. Okay, to-dos. None. Message. That's fine. Terminal. Looks okay. Project. Enable version control. Git. Okay. Good. Git's working. Okay, unversioned files. So I'll take you. I don't want you. Description, whatever, I don't care. Encodings, yeah. Shaders, no. Gold, no. I want the indexed. No, not the class. Ah. Thank you. I'll just put an asterisk there, please. Project configuration files can be added to Git. Yeah. Always add. Don't ask again. Okay. Whatever. I'll close that because I don't know what it's telling me. Save that out. Now, commit. What were you saying? 26 files. Right, that's getting better. Do I need these XMLs? It's only the Java ones that I'm really interested in. It looks like I do need these. I don't want objects. Star .obj star.mtl star.png. Okay. What about XML? XML. Something to do with codings. Okay. We'll get rid of those as well. I don't think I want to save those. Star.xml. Save. Star.shader is not. No, I do want to save shaders. Sorry. Is it looking better? Looking a lot better. And this is going to be the initial commit, isn't it? Initial commit. God, we've done a lot today. for OBJ loader setup. That's quite pleased with all of that. There we go. All done. That's better. There's a lot of missing code, and it hasn't been tested yet. I don't care. That's not the point of this. I'm building a 3D engine. I'm not building a game. I'm not doing it the way I used to do it. I'm doing it with the proper code. So, on that note, my cats want feeding. It's 5 o'clock. Well, in 1 minute time or 30 seconds time it is. And I hope that you have had a good weekend. I hope the next week ahead of you goes great. Tomorrow I've got to do the rubbish and start doing some cleaning up around here. So, especially the cat snot. But that's a different matter. In the meantime, I want you all to take care and stay safe. And if I can find the stop button, I think that's the end. Where's that stop button? Oh, right, there's the mouse. Found the mouse. There's a stop button there.